Okay, so this is the outline. Um, we'll see this outline slide again, just the way this is laid out, so I'll just get into the introduction. Um, so Homo sapiens, thinking from big perspective, we are self-aware and intelligent, but we're animals nonetheless, and our animal natures do influence our behaviors. We've developed complex societies and technologies. We've transformed Earth to meet our needs. Exponential growth and material consumption has led to anthropogenic climate change. And I have a vocabulary slide in a couple slides in case anybody needs to know what that means. But despite knowing about potential disaster, we seem unable to make sufficient progress towards managing it. So that I wanted to understand that. So comprehending climate change requires more than science. So I think a lot of people, when they think of climate change, they think about the science. What is happening in nature? How do we solve it with technology and all of that? But it's such a big problem. We need to understand it from some other aspects. And for me, I went to philosophy and psychology. So science is about knowing what's happening. Philosophy is thinking about it. What does it mean? And psychology takes a look at our human behaviors and whether those are inherent human ways of thinking, our human behaviors, are hindering our ability to manage it. Okay, so I'm going to jump into the science. Given the timeline, I obviously have to be brief on parts of this. I do want to say I welcome clarifying questions during the talk. Given the time limitations, we'll hold larger discussion to the end, but if I say something and you want a clarifying question, go ahead and raise your hand. All right, so what is climate and what is weather? There's a great saying that I like. Climate is what we expect, weather is what we get. I think this weekend was a good example of that. We expected sun and flowers, and we got more rain and snow. Climatologists define climate as the statistical average of weather over 30 years. Climate change is the temporal shift, or the change over time in climate at a location. Anthropogenic climate change is climate change caused by humans. That's the anthropogenic part, is the human part. Global warming is the increase in global average temperature. So I'm going to get technical for several slides. This is the science part. I'm an engineer, so I do understand do understand heat transfer, and I use those concepts in my day-to-day work now. But just to remind everyone, temperature of an object, and here Earth, is going to be a balance between incoming and outgoing energy. And the way that energy is transferred to and from the Earth is through radiation, blackbody thermal radiation. Everything emits blackbody thermal radiation unless you're like absolute zero. And the spectrum looks like what's shown here. It's called a thermal spectrum of an object. It's based on its temperature. And we can see the spectrum for Earth here, for the sun here. And the amount of energy is on this scale, and this is a wavelength. And without getting too much into wavelengths, it's very interesting to me that the visible spectrum is right in the center of the sun's thermal spectrum. And we might think, well, that's convenient. Well, it's our evolution has evolved our eyes to see those wavelengths. That's all it means, which is kind of interesting to think about. So the sun's emitting thermal blackbody radiation, and some of that comes and hits the Earth. And the amount of radiation at the top of the atmosphere is this heat flux, which is 1,300 watts per meter squared. And there's this concept of albedo. That's how much of the radiation is just simply reflected back, and that's from tops of the clouds, it's from snow, and even just reflected off the top of the water in the oceans. So we have a net incoming energy flux of 238 watts per meter squared. Okay, so then there's also outgoing radiance, just from that spectrum for Earth that I showed you earlier. It's a lot less because Earth is colder than the sun, but nonetheless we radiate energy, or Earth radiates energy back out into space. And if you do just a direct algebraic energy balance and solve for temperature, you find that Earth's temperature would be -1 degrees Fahrenheit on average, and that would be a frozen Earth. So what is going on? Currently, just for perspective, let's see, I'm mixing units here, so the -18 degrees Celsius, but the Earth's average temperature is 15 degrees Celsius, so there's quite a large difference there. It's 30 degrees Celsius difference. And that is, the difference is caused by greenhouse gases. And this is, in terms of the science slides, this is the money slide. This explains almost everything. A fraction of the radiance leaving Earth is absorbed by gases in the atmosphere. And I've adapted this figure from Wikipedia. I think it does a very good job of showing what's going on. So this spectrum here of wavelengths shows you where the gases in our atmosphere absorb energy. Okay, and for the most part, incoming solar energy is not absorbed, just a little bit down here in the UV spectrum. But underneath the Earth spectrum, there is a lot of gases absorbing, okay? And there's two main ones that matter a lot. One is water, and that's end up being here, and the other is carbon dioxide, and that's here. And both of those are near the middle of the Earth spectrum. So when it comes to doing an energy balance, we can account for that by just subtracting off this greenhouse gas energy flux term from the black body. I have some slides in my appendix where I've done a simple model that does all of the balancing. But this talk is more than just the science, so I'm kind of going to skip over that. I do want to say climate scientists commonly use the term radiative forcing with a symbol F for this QGG term. So if you read reports from the International Panel on Climate Change, there's a lot of talk about forcings. That's what this term is. Okay, now I'm going to get into natural variations in Earth's climate. And this is something that climate deniers like to bring up and say, well, Earth's climate has always changed. Why do we care now? Do we know it's humans? Even if humans are causing it, it doesn't matter. So I'm going to share a little bit about that. There's a number of influences, natural influences, non-human influences on climate. Over the last million years, this concept of Milankovitch cycles are the most relevant. And in the last million years, we've been mainly in a ice house climate, which is mainly ice age climate with periods of interglacials. And we're in an interglacial right now. And this comes about because Earth's orbit around the sun is not perfectly circular, and its obliquity, which is how much it's tilted, also varies a little bit, okay? And so in this figure, we can see how that changes the amount of radiation, insolation from the sun as it hits in the northern hemisphere, and that goes up and down, okay? And there's a strong correlation with the glacial periods and the interglacial periods. And we can see, if you just ignore this little bit here, this is time thousands of years before present. where this is present day and this is past history, we can see how temperature has gone up and down, sea level has gone up and down, and that has gone up and down with the insolation in the northern hemisphere. And CO2 concentration has gone up and down. They've all gone up and down together, okay? And we'll talk a little bit about the feedbacks and why that happens. But here now, since humans have been around, we're off the tracks with CO2 concentration. It's just gone way up. And temperature is following, but it didn't show up on this plot just because of the geological timescale. Okay, so there's several feedbacks that happen with greenhouse gases and vapor in the atmosphere. One important one is to talk about is our carbon cycles. There's a slow carbon cycle called the geochemical carbon cycle. This is where carbon dioxide weathers with rocks and forms carbonates, and then those carbonates get subducted into the earth. Okay, and so this is the natural way for carbon dioxide to leave the atmosphere. But it happens over millions of years. It's very slow. So if we as humans were pumping all this carbon dioxide in the atmosphere, we'd have to wait 1 million years for this to help us out. Like, that time scale is not really helpful. The other carbon cycle is the biological carbon cycle, or the fast carbon cycle. It's unpredictable and prone to upsets. You will hear climate apologists say, oh, plants will just grow faster, and that is true to a point, but if climate change is causing the plants to be stressed because of heat or drought, then that could backfire and we could end up in a really difficult position. The other important cycle is the water cycle. So as carbon dioxide is released, temperature goes up, there's more water that's vaporized. And if you remember, water vapor is also a very strong greenhouse gas. So you have this amplification effect, a positive feedback. It also affects other things like cloud cover, or melting snow and ice. And again, so it gets a little complicated, but overall there's a net positive feedback. All right, so those are the scientific principles, the basic concepts involved with climate change. The other part I wanted to research and share about is how we know. So we've been talking about theory. Well, how do we know how well those theories work out? How are we sure? There's a few direct measurements we can make. Since we've had the scientific revolution and people have been making instruments to measure things, we've been measuring temperature since the 1700s. In the 20th century, we started measuring directly CO2 measurements. And scientists are making many other direct measurements of sea level, ice thickness, wind and ocean currents. There's a lot of great science going into understanding climate. Indirect measurements are used to make measurements of long ago climate. And what I'm showing here just in the images, these are fossilized coccolithores or little plankton type microorganisms in the ocean. And some scientists discovered that if they do cores of the ocean bed, they can find all kinds of these coccolithore shells which have carbon in them, and use that to infer what climate was like way back in time. Another method is our ice cores. That's a little easier to understand. There's bubbles from our atmosphere trapped in those ice cores from thousands of years ago. So on this slide, I show this is now a some fairly famous data trends of temperature and CO2 concentration. This one became politicized and called the hockey stick graph, but you can see in the last 1,000 years, temperature was flat, even went down for a little while, and now it's going off the charts, increasing rapidly. and it correlates directly with CO2 concentration. Okay. So another way that we can know about climate and understand what's going to happen in the future are climate models. I do modeling as part of my job, so I have a special interest in scientific models. There's a number of different models and different fidelities or level of detail. The gold standard in climate science are these so-called general circulation models, or GCMs, and they're basically a form of computational fluid dynamics where they solve the flow equations in the atmosphere, both around the Earth and then up and down, at the same time solving all kinds of thermal and heat transfer balances. And so in the International Panel on Climate Change, they report on results from the general circulation models. And in the last report, which was released in 2021, they show a very good agreement between the model predictions, which is the colored solid line here, with the experimental data, which is the black line. And one interesting way to determine how good the model is they reran the model without human influences, and you can see that's this flat line down here. So this is a pretty good indication that humans are responsible for the increase in temperature. Okay, so now I'll share a little bit about what's happening to our climate, what scientists are predicting is going to happen. Before we dive into the future, we can learn from the past. So there's this, it's an interesting field, I found it fascinating, called paleoclimatology. So they study past climate. The figure I showed before was thousands of years ago. This is millions of years ago. So this is 3 orders of magnitude further back in time. And we can see the trend in CO2 concentration. Temperature's not directly on here, but ice is used as a proxy for temperature. And so the ice extent is the blue bars. And so we can see again this correlation between CO2 concentration and temperature. There's more ice, cooler temperatures, okay? Humans were just on the very edge over here. And what I found fascinating is for much of Earth's past, CO2 concentration was much higher than now. Now we're around 400 ppm. Much of Earth's past was 1,000 ppm or higher, okay? But for the last million years, we didn't have CO2 concentrations over 300 ppm. But now it's at 400 and increasing. And just by deduction, we can presume that if we don't do something, we're going back to a greenhouse climate, which is like dinosaur climate. That's a big deal. That's very different from what humans are living in now. It's very different from how we evolved from apes. That all was all during a glacial and interglacial climate. So the other really important concept that I want to share about the science of climate change is the rate of change. If climate has changed in the past, and if it changed slowly enough, species evolved and they migrated to different parts of the Earth. And it happens, most of the climate changes were on geological timescales that were so slow that over 5 generations you wouldn't even notice. It's over 10 generations that if you had a recorded history you would notice. Currently CO2 is rising 200 times faster, and temperature is rising 50 times faster than previous glacial, interglacial transitions. So it's happening very fast. I did some math to understand the difference in time to stop a car by slamming on the brakes versus crashing into a solid wall. And that difference is 100 times, okay? So we are in a climate car crash, if that helps you comprehend this rate of change. Previous climate change events have happened at this rate, and they resulted in mass extinction events. That's very clear. So that's kind of geological timescale predictions, shorter timescale predictions, like what's going to happen till in the next century. There's some very good modeling that's happened by climate scientists. And it's important to understand that predictions are just based on scenarios and depends on our human behavior and what we do on which scenario is most relevant. So there's, in the last report by the International Panel on Climate Change, they report on 5 scenarios. There's been a lot of talk about keeping the temperature increase less than 2 degrees. Only 2 of these scenarios do that. And they do that by stopping emissions by 2050 and taking CO2 out of the atmosphere. That's the only way we can manage to do that. If we don't do that, we are going to much higher levels of climate change. Temperature, of course, is just a convenient measure of climate. Temperature does matter, but there's a lot of other effects of climate change. Loss of snow and ice means less reliable water sources for agriculture and for human drinking water. There are less frequent but larger precipitation events. I think we are already starting to perceive that here in Colorado. There's desertification and flooding, ocean acidification, and many more, some indirect and unanticipated, and we just don't know how it's all gonna pan out. Okay, so this is a summary slide. I'm gonna skip over it for time. I wanna make sure we get through the other topics and have time for questions. All right, so we're gonna shift to philosophy. So climate change seems bad, but let's think carefully about it. How bad is it? Do we care? What's going on? So this slide is just kind of a general slide about philosophy. With everyone here being humanists, you probably think philosophically already, so maybe I don't need to spend too much time on this. The last bullet is that well-practiced philosophy can help us make sense of difficult subjects and see things we take for granted in a new light. That's how I like to use philosophy. So philosophy for climate change. You know, it's commonly accepted that climate change is bad, okay? So, but let's think about that. Why is climate change bad? For whom is it bad? How bad is it? And what kind of response should we have? I've struggled a little bit on where to share this slide, but I put it here in philosophy because I think there's some ethics around how scientists should communicate and be careful how they communicate. There's a famous essay by Stephen Schneider called The Double Ethical Bind, where he speaks to scientists have a very clear ethic on communicating objective information. But he made the observation that he's also human, and he wanted to communicate also his own human emotion about the subject and so on. So I understand that, and he also talks about the frustration of being misunderstood and misrepresented by media. All right, so there are some challenges here, but I think it's important that scientists never misrepresent the facts, and we never exaggerate. I think those activities can backfire and can be used by opposition in ways that are unhelpful. And we certainly do have our own personal opinion. I'm sharing some of them today, and I think it's good to recognize and communicate that those are our personal opinions. Okay, so we're going to jump into the subject of environmentalism. by the fact that climate change is about Earth's natural systems, it's an environmental problem. So I think it's good to think about environmentalism as a part of how we think about climate change. And when I started thinking about climate change and environmentalism, I dug into the literature. I realized that it's important to think about the environment and nature in our relationship with it. Okay. Certainly, nature's been celebrated and even worshipped since ancient times. I think we all appreciate nature, but it's also can be viewed as dangerous and something to be feared. And there's a lot of Western culture influence in Western culture, deriving from dualism and Judeo-Christian ways of thinking about nature, and that's influenced how we interact with nature and the environment, what's natural versus artificial, and so on. And in the 20th century, environmentalism was largely about protect nature from humans. And the nature was assigned intrinsic value. So when we talk about values having being intrinsic, that means that if something is value intrinsically, it has value all by itself in its own right. Whereas instrumental value means it's valuable to some other entity, and normally that we think of that from our perspective as humans. So if 20th century environmentalism was about environment having intrinsic value, and that worked all right to a degree, and some environmental successes were had. The ozone layer is one that's often cited, and those successes happened by saying we need to value the environment, let's fix this problem, and we were able to solve some problems by implementing slightly more expensive alternative products or just paying a little more, okay? But climate change is such a big problem, and it is involved in so many parts of our life that way of doing things isn't going to work. So we need to think about the environment and environmentalism in a different light in terms of climate change and the Anthropocene. And it really appealed to me personally to understand that humans are part of nature. We're not separate from it. Nature, if we look at the etymology of the word nature, it includes all parts of the universe and our world, and includes humans. Humans evolved from nature. We're inextricably part of it. And it's, I think, useful and helpful to think of all the ways that nature has instrumental value to humans. Certainly, it provides the air we breathe, the water, the food. It takes up our waste, and also has aesthetic beauty, and we can appreciate that as well. And for me, this framing removed the human conflict with nature. We can work together, and there's Western culture is not the only viewpoint. There's a number of other cultures out there, and in indigenous cultures where they've had this idea of human and nature integration for a long time, and we can listen to their viewpoints and learn something from it. And so I'm not the one that coined this phrase. This has come from some things I've been reading. There's this idea of environmental humanism, and I kind of like that way of framing things. So now I'm going to share a little bit of humanism and humanistic perspectives, very relevant for this group. So just to talk a little bit more about environmental humanism and humanism in general. Humanism is about helping humans flourish. That's part of the ideas of humanism, and to reduce human suffering. And keeping Earth's ecosystems healthy and maintaining a stable climate will increase human flourishing. So there is the reason why we should do something about climate change. But to understand how how important is it that we keep humans flourishing? Let's think about the values of what is the value of a human being, and where those values lead us. And it was helpful to me to think about human extinction as kind of the worst case scenario and all the lost value there. And that would help put things in perspective. And it's good to remember there are many existential threats to life on Earth other than climate change. And eventually, the Earth's going to be consumed by the sun in millions of years. We're all going to die. So what does it matter if humans go extinct a little earlier than later? I don't have a full answer to that, but I've thought about that. Okay. And there's some very interesting philosophical writings out there. Forgetting there's a book called Death, and by Shelley Kagan that I read that was I thought that was very informative to me. And there's a way to think about death where once we're dead, we're not capable of mourning our death anymore. So once we're dead, why do we care? And if we follow that line of reasoning to human extinction, why should we care about the end of humanity when it occurs many years past our deaths and our children's death? What's the big deal? So, same thing with human depopulation. Like, again, the first thought is, oh, that's got to be bad. But depopulation by lower birth rates, I think most people would accept that as that's okay. Depopulation by war, disease, or starvation is not okay because there's human suffering involved. But it's good to think, too, that if there's too many people on Earth, that tasks Earth's resources and accelerates climate change, and that's going to lead to suffering. So we have to find some balance. And if I went through this thought experiment or scenario in my mind, that what if there was a lot of suffering during a depopulation event? That wouldn't be very good. But if future civilization was stable with high human flourishing for thousands of generations, the net value would be a plus, right? So just some scenarios to think about. I'm not saying we should all go drink some poison Kool-Aid to help future generations right now, but you know, this kind of framed things. So pulling it together, let's think about how we manage human flourishing in this very challenging time of climate change. And fossil fuels get a bad rap, but fossil fuels have enabled immense human flourishing. Lots of wealth, lots of improvements to health. And along those line of resources, we can think of the capacity to emit as a resource. And this graph down here shows amounts of emissions and what the temperature increase would be. Okay, so we can think about how much more emissions do we have? Who gets to emit them? Do we get to emit them now? Should we save them for the future? Does the United States and developed countries have a right to continue emitting, or should we stop and let developing nations emit to bring up their standard of living? These are important questions to ask. You know, this idea of luxury versus survival emissions, and what rights do we have for continuing to emit? I think, yeah, this is my last slide for the philosophy section. It's kind of just a little shift from the deep thoughts we've had, but in philosophy there are ethics, and we can think of ethics that we might consider having for ourselves. And these bullet points here are just some that I've thought about and some that I might aspire to. You know, ideally, ethics would be cross-culture right away, and that would help solve the climate change problem. But that's impractical. So I tried to think of some ethics just for myself that I could be happy with, and I wouldn't be upset if other people didn't follow them. So just to mention a couple here, one is to become educated about what really makes a difference. And it turns out what's intuitive is not always true. And Hannah Ritchie just published a book called Not the End of the World, and it's all about data, about what really makes a difference. And it was a good read. Another ethic I like is just to reduce consumption of energy and raw materials where I can. And I think everybody can appreciate that one. Eating meat does make a difference, but I like to eat meat, so I'll eat less. And then this one I really have thought about quite a bit recently is to participate more in community groups and to get satisfaction out of that. And that can lead to higher quality of life without necessarily consuming a bunch of energy and the need to travel faraway places and so on. Children is a hot button topic, but it would make a difference to have fewer children. And it's a very, I'm talking about personal ethics. This is a very personal thing to consider. It's also important to think that these ethics should align with other parts of our lives, not just climate change. We all have a spectrum or a whole experience in our life. It's not always about climate change in the moment. Okay. All right, so the third topic is psychology. And I'm doing okay for time, so that's good because I do have a bit on the last topic, which is potential solutions. Okay, so why think about psychology when it comes to climate change? We spent some time reviewing some philosophical topics that are relevant to climate change, and philosophy can help us think rationally about climate change and suggest fair and equitable ways to mitigate it. But what we do doesn't always align with what we think. It's part of being human, part of being an animal. And this is especially true with climate change. And so psychology can help us understand this dichotomy. So psychology of climate change, I'm not the first one to think of it. There's a few books out there already on this topic and some literature. But innate human psychology is challenged by the climate change problem. And one of the big problems is we just have a lot of negative feelings and reactions to it. We know it's bad, but we feel like we can't do anything about it. So there's anxiety, feeling overwhelmed, maybe even despair. And our behavior, our reaction can be denial, rationalizing, avoiding the topic, just not talking about it. And in many cases, especially here in the United States and our developed country, we can have cognitive dissonance because we know our lifestyles are part of the problem. And so that can be uncomfortable. There's been some recent discussions in the literature and the media about climate grief. I think that is a real thing, especially in the generations going through college now, that they report grief about climate. And it helps to think about the 5 stages of grief: denial, anger, bargaining, depression, and acceptance. And one of the goals in my work in presenting and sharing is to help people to get to acceptance sooner, because that's where progress can be made. So climate change is hard to comprehend for most of us. It happens on geological timescales, and we saw that in the science presentation part. But our human brains, respond best to the here and now. And denial and avoidance are common when we don't like the subject and its distance. And climate change is distant in several ways. One is time. The other is space, climate change in the moment is affecting people elsewhere. I'm doing okay, today's a sunny day, not a big deal. And another way it can be distant is frequency. Climate change doesn't mean we're warm all at once every day, but it comes and goes with extreme weather. And so we might have an extreme weather event one year, but then not again for several years. So it's easy to put it out of our minds. But climate change is accelerating, and so by the time it becomes perceived as a near-term threat, it will be too late. So we need to deal with it now. But how do we deal with it? Well, more rhetoric is not working. The climate change and basic solutions are clear. We know what to do. But the people involved in climate science and climate activists, they work harder to educate, they share more doomsday scenarios, policymakers do more studies and make promises. And a lot of the framing has been about individual lifestyles, blaming and shaming, okay? All of these things are not effective. Basically, the people that know about climate change are already doing everything they can, so this isn't helping. And those that are apathetic or in denial just become more entrenched in their apathy and denial. So that leads into the next section, which is evolutionary psychology, and that can frame, perhaps help us frame a way to make some progress and overcome our shortcomings in the way we think. So if you're not familiar with evolutionary psychology, I came across this a few years ago and was fascinated by the subject. In the same way that our physical attributes, or standing upright, opposable thumbs, those came from evolution, natural selection. In the same way, our ways of thinking and our human behaviors were naturally selected. They evolved to what we have now. And we've evolved to have complex social behaviors, and they're highly malleable. That's one important point that people who write about evolutionary psychology like to make a point about is, although we've evolved to have certain ways of thinking, it's not the same all the time, and they can change, but nonetheless they are evolved traits. Okay, so this is kind of an extension to how it's hard for us to think about climate change because it's distant, but it bears worth repeating, and it comes from our evolutionary origins. Our survival instincts respond best to present and near future threats and opportunities. And physical danger and important social situations, they really evoke strong emotions and action. And although we can think about climate change and we can understand it conceptually, it's a bit esoteric and intangible, and it doesn't evoke emotion and immediate action. There's some, so for those who are really, climate activists and people who believe strongly about climate change, they try to redirect the threat in their mind to something more tangible and communicate that. So like, climate deniers, they're the problem, or fossil fuel companies, capitalism. Okay, those are a little bit nearer. We can say those are the problem, right? But this has limited effectiveness. It's not universally appealing. Not everybody gets it and agrees with them being the targets. And those targets aren't the fundamental cause of climate change. So there's only so far we can get with that approach. The other part, or another aspect of evolutionary psychology that I want to bring up is that our natural human behaviors are that we are resource extractors and builders. That's what we've evolved to do. That's allowed us to be very successful as a species. And part of that has been extracting and using fossil fuels, like I already mentioned. That's been a very valuable resource. We have a high aversion to giving things up and going without. Once we have something, we don't want to go without that. And so, a lot of the rhetoric about we need to stop using fossil fuels in order to save climate change, it just is untenable without a practical replacement. Okay, so there's been a lot of, I've talked a lot about what is hindering our ability to solve climate change, our mismatch of our evolutionary psychology with the problem that we face. And it's easy to, when we think about evolutionary psychology, to focus on the negative observations. But we can use insights from evolutionary psychology for good. And what are more productive policies that would go with our natural human behaviors? And I mentioned some here that have come to my mind. I can't say these are all the answers, but let's stop with the guilt and shame messaging. It doesn't help. No one wants to be part of the solution if you're made to feel shame. Let's think about ways to incentivize rather than punish and regulate. And I'll mention again community. Let's appeal to the sense of community. We're all in this together. We're all on one earth. Let's see what we can do. Okay. Another part of thinking about human behaviors, human psychology, is how we've grown to make complex human societies. This is a really important part of where we're at today in our modern civilization. I like this quote from Yuval Noah Harari: "Sapiens can cooperate in extremely flexible ways with countless number of strangers. That's why sapiens rule the world." But there are also some challenges from our societies. Tribalism behaviors can cause some challenges. I mentioned this Easter Island as an example. If the history is correct, on Easter Island there were multiple tribes. It wasn't all one tribe. And they were in competition with each other to show off who could make the biggest monuments. And that led them to spend so much resources making those monuments, they cut down all the trees, and that had an eco-disaster. So I think that's a good analogy. There's this idea of the tragedy of the commons that is commonly mentioned on these types of problems. Okay, so we have a modern civilization. It's built on massive and interconnected institutions and economic systems. Consequently, climate change is a wicked problem. There's this idea of wicked problems being problems involving complex interactions between social institutions. But the physical principles of climate are also complex. So we have like an ultra wicked problem with climate change. It's such a massive problem, it'll require massive solutions with massive changes in culture and society. And it seems insurmountable. But as I mentioned before, evolutionary psychology and our behaviors are highly malleable, and it's hard to predict how there are moments in history where humans did suddenly something very different, and sometimes behind a charismatic leader, sometimes behind a grassroots movement. So maybe there'll be a social movement yet to lead to change. I don't know. All right, so let's get to a way forward where I offer my perspective on a few solutions, and then I want to leave time for some questions. So I'm skipping over summary slides because I can see I want to stay on time. But like I mentioned, a lot of the things that have been, a lot of the messaging and even the solutions haven't been working. A lot of the mitigation efforts have been little more than greenwashing by corporations and virtue signaling by humans. There's not a whole lot of material headway. There's a few in the electrical power, switching to solar and wind. There is a tangible, some tangible results happening there, but there are other areas not so much. Like I said, austerity, giving up fossil fuels is not really tractable, so just giving things up isn't going to work. We should instead acknowledge and accept the limitations of human psychology and our current societies. So let's embrace human nature to build and change. Let's leverage our existing human institutions. We have a lot going for us. When we put resources behind it, we can do a lot. there's this idea that we've disrupted Earth's system so badly by accident that the only way out is to continue disrupting Earth's systems. But let's do it intentionally and carefully now, if we can. Yep. So I mentioned some technology solutions that I have hope for. I work in the industry, so trying to do what I can. First thing is there's a few things that are obvious and that we can do right away, which are efficiency upgrades to everything. Buildings especially, cars as well, electrification of energy where possible, so electric cars, and nuclear power. Nuclear power has had a lot of bad rap by environmentalists, but if environmentalists care about climate, they should change their tune because nuclear power is carbon neutral. Then there are some new technologies coming along that are really where we can do a lot. So there's carbon capture and storage. I work in the field of point source carbon capture, so this means capturing the carbon right out of the smokestack of the power plants. And then storage means putting it underground or some other long-term storage. Direct air carbon capture, or DAC, DAC, means pulling it out of the air. This is more involved, it's more costly, takes a lot of energy. That energy, of course, would have to come from renewable sources. But I think we need to do that too because we're already over 400 ppm and we need to bring it back down to 300 ppm. So we got to pull it out of the air as well as stop emitting it. There's a lot of other ideas. We can use biomass as the direct air carbon capture mechanism. They grow, they take the carbon out of the air, and then we can do something with the biomass to put it in permanent storage. So that's a way to remove carbon. And then there's a few ways of utilizing the oceans to pull carbon out and store it. Kind of as a last resort, but it's important to think about and be ready for, is this idea of geoengineering. So geoengineering is this idea of doing something in the atmosphere or the sky to reflect more of the sunlight, and that's a direct way to get cooling. There's a number of challenges, but it turns out that it's fairly inexpensive to do, is to pump a bunch of sulfur particles in the atmosphere, and it'll work, at least on paper. And we need to start thinking about adaptation, so weather resilient infrastructure, high-tech land management for food production as rain becomes more unpredictable. The other thing I want to mention is we can leverage our existing institutions, namely capitalism. Capitalism has driven rapid human progress. To say it's the problem with climate change is understandable, but I think it's a mistake. If people say capitalism needs to get out of the way, the governments need to be directly involved or more directly involved, well, it's kind of the wrong way to think about it. Capitalist markets don't exist by themselves. There's always been government regulation. Maybe we need to reframe how that regulation is implemented and how the capitalist markets work, but let's go ahead and use it because it does work. And we can do that by implementing market incentives. There was a lot of talk about carbon taxes, cap and trade. Those didn't get traction here in the US, at least not yet. California has a cap and trade program, I think. But the bipartisan infrastructure law put in direct monetary incentives for carbon capture and storage. So that's how we're doing it at the moment. It's not enough, but it's a start. Nonetheless, there's a big problem, and that's how to convince citizens around the world to pay for the market incentives. And I don't have an answer for that, but that's really where the rub is. Beyond technology and markets, I mentioned hope in a grassroots worldwide social movement. We can hope that happens. We need to be careful to avoid nationalism and protectionism, to just become insular and protect our own resources and say to hell with the rest of the world. We can start thinking about pre-planned migration. That's a tough one, but we might need to do it. And also we need to consider that we may not succeed at keeping Earth habitable for 7+ billion people. And what does that mean? How can we reduce the number of humans in a ethical way with limited human suffering? So, conclusion, climate disaster or not? I think it sure looks like it. Thinking philosophically helps put the consequences in perspective. Understanding human psychology helps explain the slow progress. But there is still hope. We must appeal to human ingenuity and embrace technology. The goal should, of course, be a humanistic perspective of human flourishing today and in the future. And I think, it's been very helpful for me to think as an individual, climate change isn't necessarily my personal fault. Let's get to acceptance and move on. And just have one more statement here. Accept who we are, appreciate humanity as it exists now, do what we can to keep our species thriving, and acknowledge the future is uncertain.